Hey everyone, it's Mrs. Brimlow, and today I'd like to talk to you about scientific notation. So there are a copy of the notes attached in Canvas, or you can get a copy when you return and just watch the video. Okay. So this is what the notes look like. So this is the math standard we're working on, our objectives, what you should be able to do when you're done with the lesson, and just the general understanding for this, little synopsis about what we're learning. Okay. So, writing large numbers in scientific notation. So, when we use scientific notation, a lot of go to examples have to do with space, with the type of numbers we're talking about. So, Louisa is researching the approximate distance between Earth and the Sun. Her father told her that the distance is 9.296 times 10 to the seventh miles. In an astronomy book, she found the following: which distance is correct? So this is what her dad told her the answer was, and this was the answer she saw in the book. So we're going to compare them to see if they're the same. So we would say that this example is in scientific notation. We're going to break that down a little bit more here. So Louisa's father used scientific notation to express the approximate distance because the distance is so great. So when we have really long numbers, so it represents a really big number, or if it has a decimal and it represents a really small number, we can shorthand write it, kind of like with doctors or when you abbreviate things. That's what scientific notation does for those numbers. So in scientific notation, there are two parts that we have to be aware of. The first part is our first factor, and it is always a number greater than or equal to 1. So make sure you write that in, and less than 10. Okay. I'm going to go and highlight this too. So first factor, always greater than or equal to 1 and less than 10. Okay. So that's our first factor. The second factor is always a power of 10. So, second factor, always power of 10. So we have a base of 10 to some power. Okay. And the reason we do that, as we've talked before, is by working with tens, it allows us to move our decimal point as needed. Okay. So this is how it should look in scientific notation. Now, what if I wanted to see what this looked like or rewrite it in what we call standard form, how we're traditionally used to working with numbers? Okay. So based on the scientific notation, okay, we place a decimal point after we're going to count over how many digits that the decimal needs to move. So because this is a positive 7, you're going to move to the right, okay, and we count, so in this case, 7 spaces because that's how many times they want it to move. 1, 2, 3, 4, 5, 6, 7. So that's where we land up right here. Okay. So you place that decimal after that last digit. Okay. We count the number of places, and that's how we figure it out. Okay. So the two numbers represent the same distance. So when it's positive, move right. When it's negative, move left. Okay. So I want you to pause and try this example where you write this number here as in scientific notation, then come back. So at the end of this number is technically where the decimal point is. So in order for this first digit to be between 1 and 10, we'd have to move it to where the comma is. So it would look like 3.212. Whenever you're writing a number in scientific notation, you need to include all non-zero digits. So if this was 3,202, so this is 1 was a 0, you'd still need to include that last 2. So you can stop at that point. Now, in order to get from this back to my original number, I'd have to move it 1, 2, 3. That's how many times I moved it. So it would be to the power of 3. And it's positive because if I was to move this decimal point, I'd have to move it to the right. Okay. Let's go ahead and flip to the back. Look at some more examples. So another time we can talk about them is when we're talking about really tiny things, a lot of things you can't see with the human eye. But those numbers are really long because they're really small. So, what is the width of a red blood cell written in scientific notation? So, they give us a picture here with the distance in standard form. So, we're going to write the number as the product of two factors. So, once again, we're going to place the decimal after the first non zero digit. In this case, is 7. Okay. So, this is going to look like 7.03 because we need to include all non zero digits. Now, we know we're going to have a base 10. So we move that decimal point 6 times from where it originally was to where it is now. And in order to move back to the original place, we'd be moving to the left. It's a decimal number, therefore it's going to be -6. So when you have a number that comes after a decimal, that means it's going to be negative because the original number would have to move left. If it's a whole number, then it's going to be positive. Okay. You can pause and try example 2 at the bottom, and then come back and check your answer. Okay. So the first non-zero digit is 5. So it'd be 5 times 10. Now this is less than 1, and I'd have to move it back 1, 2, 3 spaces, so it would be to the -3 power. Okay. All right. Last example, we're going to look at converting scientific notation to standard form, and specifically when we're working with calculators and technology. So Kelly used a calculator to multiply some large numbers. How can you write the answer on her calculator screen in standard form? So you're going to notice that it says 3.5E15. So 3.5 is your first factor between 1 and 10. And then E stands for exponent. So exponent of 15. So that means it's 10 to the 15th power. We always have base 10, and then whatever is after the E is your exponent. So in this case, 15. So once again, if I was to write this out, I have a positive 15, meaning I'm moving my decimal point to the right. So it's going to be a number greater than 1. And I'm going to move it 15 times. I like to actually physically rewrite the number and then move the decimal point that many times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then all those blank spaces are getting zeros. So we only had one non-zero number to move it by, meaning that, see, like this is already making my eyes go a little crazy because it's a lot of spaces. We'll typically work with some smaller numbers, but this is what they gave us for the notes. So it should be 3, 5, followed by 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. When you have numbers this big, you should go back and count every 3 numbers you put a comma. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. 3, comma. Okay, that's what it should look like. Right. So same thing here. So 8 is my first factor times e to the -9, so 10 to the -9 power. When you have a whole number like this, the decimal point is technically after it. -9 tells me I'm going to move to the left 9 spaces. So 1, and then to get to 9, we'd move it 8 more times. 1, 2, 3, 4, 5, 6, 7, 8. So we moved it a total of 9 times. So there should be 8 zeros and then 8. Okay. And now you can pause and try example 3, and then come back and check your work. So to the 8th power means I'm going to move this decimal 8 times, and because it's positive, it's moving to the right. So, like I said, I like to actually draw it out. Oops, it's a 5. 1, 2, 3, 4, 5, 6, 7, 8. All these extra spaces are zeros. So I'm going to rewrite it so it's a little bit neater. So I have 1, 2, 3, 4, 5 zeros. Then I go back, add my commas, a little cleaner. So this is 922,500,000. Okay. Now this one is also 8, but it's negative, meaning I'm going to move it to the left this time. So 1, 2, 3, 4, 5, 6, 7, 8. So that means 1, 2, 3, 4, 5, 6, 7 zeros. So like I said, I just like to rewrite it again so it's a little bit neater. So I had 7 zeros and then 6, 3. Whoops. Okay. So once again, today we learned what scientific notation is, why we use it, and then how to convert between scientific notation and what we call standard form. our numbers we're traditionally used to working with. So you can see what's available in Canvas for practice, or you can see me. Make sure you get a copy of the notes if you didn't take them. If you have any questions, reach out and I will chat with you soon.